Welcome. In this video, we're going to look into two things. One, the various EV charging options that you should consider before purchasing an all-electric vehicle. And two, we're going to take you through a detailed installation of a level 2 charging station for home use. Here we're looking at the 2017 e-Golf from Volkswagen. It's built on the same platform as the diesel, hybrid, and gas version of the Golf. A glance at the interior reveals the same appearance across all the drive systems. The lack of a space-age looking interior for this EV was an intentional choice by Volkswagen, as they wanted the driver to experience a seamless transition to the EV world. Whether refueling or charging, the driver goes through the same motions and performs similar functions. On the e-Golf, the fuel port has been repurposed as the battery charge port. In the USA, the SE model uses the J1772 charging standard, while the SEL model adds an SAE combo plug, also known as a CCS1, which enables rapid DC charging. Along with range, charging is a major concern to potential EV shoppers. By the way, none of these devices is the actual charger. They are technically EVSE, Electric Vehicle Supply Equipment. The charger is the onboard device that receives power from the EVSE and converts it to DC voltage that is used by the battery. For simplicity's sake, we'll just call the EVSE the charger, but now you know the difference. When I first considered getting an EV, charging was the issue I was most concerned with. I had driven a friend's Chevy Bolt and was impressed with its performance. When I inquired about the expense of installing a charger, I was told they just plugged it into a wall receptacle. It was this epiphany that convinced me to go ahead with my purchase. Let me explain. One option for charging your EV is to use the Level 1 supplementary cable that's usually supplied or can be purchased separately. Looking at you, Tesla, the cable has a 3-prong plug that plugs into a 120 receptacle. The other end has a J1772 connector that fits into the charging port. Tesla has its own proprietary plug. The advantage to this charging system is that it's already included with the vehicle purchase. Most garages have an electrical receptacle or can have one easily installed. The disadvantage to this system is that it can take a long time to charge your vehicle. My cable is rated at 10 amps, which at 120 volts equals 1,200 watts, 1.2 kilowatts. If I divide that into the battery capacity, which is 35.8 kilowatt hours, I get a charge time of almost 30 hours to fully charge the battery. But wait, before we discard the supplementary charging cable as being impractical, let's do some more math. The average US work commute is 40 miles round trip, after which you can plug in your car until you need it for the next shift. Let's say you left for work with a fully charged 125-mile range. Upon returning, there would be 85 miles left. Plugging into a 120 receptacle gets you about 4 miles per hour. That's 35.8 kilowatt hours divided by 125-mile range, which gives us 0.2864 kilowatt hours per mile. To get miles per kilowatt, we divide 1 kilowatt hour by 0.2864 kWhm. That gives us 3.49 miles per kilowatt hour. To get miles added by the cable, we take that 3.49 kilowatt hours times 1.2 kilowatt hours, which gives us 4.19 miles per kilowatt hour. Thus, in about 10 hours, the battery should be full. We take our 4.19, round that out to just 4.2, to make the math simple, times 10 hours, that gives us 42 miles. What if you drive more than the average? Well, you can leave your car plugged in, let's say 14 hours. That would get you up to 58.8 miles. So conceivably, you could drive up to 58 miles a day as long as you left the vehicle plugged in for 14 hours to charge. What if you exceeded the 58 miles in a day? You would come up slightly short of full for the next day, but you'd still be able to make your 58-mile trip and then some. The range shortfall would close up on shorter drives or on the weekend when the EV is just sitting there doing nothing. Did you know that the typical car is parked 95% of the time? That's a lot of time for charging. And of course, you don't have to fully charge the battery pack to full each day to use the vehicle. You just need to charge it enough for the range that you're going to be driving that day. Thus, level 1 charging can be practical for most people, as it was for my Chevy Bolt owning friend. Level 2 charging offers faster charging rate of 4 to 5 hours to fully charge my e-Golf. Level 2 is the dominant charging unit that you'll see out in public spaces. The cost of using these stations can vary from free to some established rate. I personally have yet to pay for public charging, as I just take advantage of all the free ones that are in my area. The disadvantage to level 2 is you have to locate one that's nearby, and you have to hope that it's working or that it's not occupied. Of late, I've come across damaged and unmaintained charging stations, which can be an inconvenience. Of course, a level 2 charging station can be added to your home, although the installation cost is much higher than for level 1 station, as it requires 240 volts and somewhere between 20 to 50 amps of service. Finally, there's DC fast charging, sometimes erroneously referred to as level 3. They can charge my EV to about 80% in less than 1 hour. Due to the high costs and power requirements, these are not available for home use, but are available in public spaces and usually require a fee. The real question for potential EV owners is, can you drive within the limitations of level 1 charging? If so, you're set, knowing that alternate level 2 charging is also available in your area when and if needed. Or you might decide that public level 2 is sufficient for you. I did that for years in Los Angeles without any inconvenience. I only used my level 1 cable once, and that was just to make sure it was working. Upon moving to the East Coast, I discovered plenty of free level 2 stations, and there was no need for me to install a charging device at home. Thus, depending on your commute and the available power sources in your area, it's possible to use level 1 only at home, or public level 2, or some combination of the both as needed. While it's an easy mile walk home from the nearest level 2 station, as I get older, I started thinking this might not be my favorite walk in the wintertime. While level 1 is definitely a doable option in my garage, it is less efficient due to the lower voltage. So I looked into installing my own level 2 station. I knew that by not hiring an electrician, I could easily save over $1,000 on installation. But I had to make sure that the work met or exceeded the local electrical codes and that it would pass inspection. Of course, I'm no stranger to working safely with electricity, and by all means, hire a professional if you do not have the skills, because it's not worth risking your life or property. My first step was to determine the maximum current the onboard e-Golf charger could use for level 2. By using Ohm's law, that's watts divided by voltage equals amps, I was able to determine that the onboard 7.2 kilowatt charger divided by 240 volts equals 30 amps. I also wanted to have some extra capacity so that if I decided to upgrade to an EV with a larger onboard charger, I could do so. I figured 40 amps would be sufficient. Now I needed to determine the circuit breaker that I would need, and per NEC code, device amp times 1.25 will tell you the type of circuit breaker that you need. In my case, 40 amps times 1.25 equals 50 amps. Now this number allowed me to determine the conductor size that I needed for the cable. NM-B83 is rated for 40 amps, which is too low, while NM-B63 is good for up to 55 amps. Thus, 63 would be our cable of choice. With the circuit breaker and cable size determined, the next step is to see if your electrical service panel can handle this extra load. Ideally, you want at least 200 amps of service coming into your home. If your electrical panel does not have enough capacity, your choices are either to upgrade your electrical service or to settle for level 1 charging. We're looking at the open box for the circuit breakers that are for the heating system. The heating system is no longer used, so these are all available. At the moment, there's a 100 amp circuit breaker that feeds this sub panel. It has been tripped off. I've gone through with my meter and verified both that there's no voltage and that there's no back feeding via any other lines. Right now I'm checking continuity, and I've discovered that the neutral bus and the ground bus are bonded, which is a no-no for a sub panel, but was okay back in 1968. So that's an issue I'm going to have to address. These are all the 20 amp circuit breakers, 240 that I'm going to leave in place except for one. I'm probably going to break out over on this side. More than likely, I will disconnect the wires so that when we activate the 100 amp circuit to this box, you can only trip one thing. If you trip something, if you turn something else on, nothing will happen because it'll be dead-ended here. So it's just a safety thing. I don't want these wires being fed. So for my particular situation, I've decided that I'm going to use replace this circuit breaker here because it comes in on this side. There are two wires that are coming down. So by removing those two wires, I should be able to just send a 6.3 up quite easily and make it up into the attic. To remove these, you're going to need to use some kind of a pry to get in here and push. I used a screwdriver to break it loose. It's very loose right now because it's not fully seated, but you're going to push it out this way and then lift out. And again, there's no current running through this system. There's a contact, and there's the other contact from each side of the bus, because that's 120, 120. So because they're being shared on one circuit breaker, that's how you get 240. So what I'll do is, there are screws right there. I will remove those screws, and then I will put in my 50 amp circuit breaker here, and then I will run my line up. Usually you run the line in, but in our situation, I'm not going to tear this out to do that. So I will break that connector loose. I will tie this wire onto my new 6.3. Then as I pull that wire up and out through the attic, I should be able to have the other one just follow through. So basically it's going to be my my fish tape. So that's the plan. Hopefully I can execute it. Oh, as far as the ground bus and neutral, so what I'm going to have to do is see about getting a ground that I can attach probably on this side. I have to see what fits in this box because it's done by brand. So this is a Bryant box, so I need to find something that's compatible with a Bryant box, which I know Eaton does make one that it is compatible. Then it's just a matter of location. And also there's this weird thing where there's a nail coming through here from this box, and that needs to be disconnected because that's just causing these two to bond together, and that's not a wise thing for it to do. So if I get this done right, the ground will be going on its own bus to the case. The neutral will go back to the main circuit breaker, and there it gets bonded with the ground because that's the way it's supposed to work. So hopefully I can execute that. The nice thing is that none of these neutrals are crucial to this because right now we're only going to use one circuit breaker out of this whole box. In the future, I may come back and, put in a 15 or a 20 amp circuit for something else. But at this point, these are just all going to be dead. So at this point, I've taken out the old circuit breaker. I've disconnected the wires that belong to that particular circuit breaker and to the one below it, only because those two circuits actually go up into this feed point. So I'm just going to pull both of these out. Again, this is a totally dead thing here. So I can afford to lose these wires. So they will basically pull the new wire up into the attic for me. For our cable, we will be using Southwire Romex 6.3. It's a 25 bundle. It's for indoor use only, dry location. It's PVC insulated and copper conductor up to 600 volts. And it's UL listed. All the cables coming into the sub panel go through an NM connector, and that's for non-metal for Romex like this, which is just sheathed in plastic. And this is what it looks like. This part goes on the outside of the sub panel, comes through the knockout. You have this fastener that catches it, and you put that up so it's held tightly into the sub panel. Your cable would go through this opening, and then you tighten the screws on both sides until the cable is snug. So that does two things for the cable. One, it keeps it in place, and two, it keeps the sharp edges from the knockout from hitting that cable. Of course, the challenge we're facing is that while these fasteners are easy to take off, I can't undo the clamp because I have no room. This panel sits flush. So fortunately, I was able to use this 3/16 rounded long screwdriver to go within this little gap here and actually unscrew the clamp. So I was able to free it. But what I discovered was that opening, which is called 3/8, is too small for the cable. So I had to go and make another punch out. And you'll see these punch outs have concentric circles. So you could just knock out that little bit, knock out more, or come out even bigger, depending on the needs of the cable that you need to push through. Unfortunately, some of them, like that one there, is just one size, which was the situation here. So I couldn't make it larger without getting some type of tool to bore it out. So I just went for this punch out, and now I have my cable tied off. And instead of using the metal, non-metal adapter, I'm using a plastic one, and that allows me to actually push this up like that one there and push it into position. So it protects the cable from the sharp edges, and it also locks it into place because you can only push the cable up, not back. These cable connectors come in a variety of sizes, 3/8, 3/4, and as you'll see in this photo, the dimension numbers aren't the actual real dimensions. So you sort of have to just figure out which one you need, which is why I ended up buying two. Unfortunately, I needed both. So in this situation, it worked out. I've pulled out all the remaining wires off the circuit breakers. Talking to the inspector, he says I can leave the circuit breakers in place as long as there's no wires connected to them. So I'm going to dress those out of the way. It also makes this a lot easier to work with. And now we're ready to try to push this cable up through the opening and pull it up from the attic. And hopefully, if it doesn't bind up on the joist above, we should be able to pull it through. Otherwise, I'm going to have to drill a larger opening up above. The fact that I can leave the unused circuit breakers in here is nice because I don't have to purchase any blanks for the panel. We were able to use the old cable as a fish, so I pulled, my assistant pushed up on this cable, and we were able to get it up into the attic. And so now our adapter, our connector adapter, just goes into place. I might have to just tap it in so it snaps in, but that'll protect the cable as we continue pushing the appropriate amount of cable length up into the attic. Due to the fact that our Bryant sub panel does not come with a ground bar and they're no longer in business, I had to find a compatible ground bar. This one has two places where I can ground out the bar to the panel, so I'm hoping that'll work. Things to note about ground bars are that they're made for specific panels. That'll be on the packaging. Make sure you pay attention to that. Not all ground bars include the lug. Sometimes that's sold separately. So make sure that if you need one, your either comes with it or you purchase it. This ground bar, the screws on it have also a square head, which is nice for especially when you're torquing. Torquing information is included in the instructions. Make sure you pay attention to that. This bar allows you to mount in two different positions on the sub panel and comes with those mounting screws. The beauty of the square head is that your driver just drops in and there's no slipping like you'd get with a straight blade or even a Phillips. It allows you to apply maximum torque without rounding out the fastener. The installation took a little longer than I expected, only because the second mounting screw, I had to drill a little hole into the cabinet because it didn't line up with the existing holes. And so once I did that, this is self-tapping, and it completed the installation of our ground bar. My white electrical tape finally showed up, so that, along with a pair of pliers and scissors, will allow me to cover the neutral in white tape except for the very end, which then I will mount on the neutral bus that'll go here, and that will insulate this from the box and the two load cables. Here's the neutral covered up in white tape. We use the pliers to just wind this up a little bit so that it's nice and tight, and then just cover it from as far back as we could, just leaving a little bit, about an inch or so of the tip exposed so that it can be mounted on the neutral lug. Here's the antioxidant compound that we're going to be applying to the end of the neutral cable, which then will connect to the neutral bar that'll go where this marking is right here. Now, the challenge is I can attach the neutral bar to the box, and then I have to try to wiggle the end of this neutral cable to it, which is going to be challenging, or I can just bring the bar up here, attach it directly to this, then mount the bar to the back of the box. The problem with that is the screw that attaches to the neutral bar is right behind where the cable lays. So it's going to be a bit of a challenge. I haven't decided quite yet which way I'm going to go. I'm going to try what I perceive the easier way, which is attach the neutral bar to the cable, then to that, but we'll see what happens. I've managed to get the neutral cable behind the red coming down, but I really have no ability to move that cable up so I can get to the clamp. So I'm going to try plan B, which is to remove the neutral bar, attach this to the neutral bar, then attach the neutral bar to the box. I added the antioxidant compound, attached it to the neutral bar, and had enough room to tighten that screw back there that mounts the neutral bar to the box. This is not fully tightened yet. I'm going to pull the cable down a little bit and then secure it. And then we'll be done with our neutral bar. We torqued down to 50 pounds on that fastener. Since I have to go up into the attic to finish pulling the cables, I wore protective gear that included work shoes, knee pads, gloves, lung protection, vision protection, helmet to protect against nails, and of course a light so I could see up there. While drilling a hole to get my EV cable into a cavity, the drill went sideways and hit another hole that had a 15 amp yellow cable, which I destroyed. Fortunately, even though that cable was hot, the drill didn't ground out and there was no short circuit, but I did have to replace the cable. Fortunately, I was able to replace it with an unused 15 amp cable that was laying up in the attic. So now that's dedicated to a 15 amp receptacle. And yes, I did manage to complete the drilling for the EV cable without any further incident. With our neutral bar secured, Now it's time to deal with our EV cable. What I'm going to do is cut the sheathing off this cable so I can run the ground to here. And then I'm going to bring the neutral over to this side. There's a red and black, and I'm going to put a 50 amp circuit breaker here and tie into that. So you got to make sure that you allow yourself enough wire so that you can reach everything that you need to go to. In my case, I'm just going to come down the left-hand side of the box, come underneath, and then come back up to get to the neutral. For these cables, which are separate circuits, which we're not getting into, I may route those just this way and around. But as far as routing goes, you just want to do something that's neat and clean and doesn't look like a rat's nest. To cut the cable, I'm using a utility knife. I don't know if you can see that tip there. Just a very small tip is what you're going to need. What you don't want to do is you don't want to cut into the sheath of the individual wires. So it's a very light score. You're just scoring this so that you can just peel it back. So you don't want to go in too deep. Just a slight score and you should be fine. I've scored the cable down to here. I just want to show you how easy it is once you score the cable. It just kind of just peels right off. So I'm going to take that right up to about here, and then that'll expose my red, black, white, and ground. From the bundle, I've broken away the ground wire, which I took to the very back of the box. I'm bringing it down, doing a service loop, bringing it up to the ground bar, and securing it with one of the fasteners. And my neutral, which is my white, is going to go over here. So I'm going to route that underneath and over to one of these screws. So we did the ground first because you always do ground first. Then we did the neutral. I brought that down, put a curve on it, put another curve, brought it up, and then found a lug that I could put it into. I took off about 1/2 inch of insulation, put it through, tighten that down. If you have a torque specification, then you go for that. And just make sure it doesn't poke out and touch the box, because then you're going to be grounding your neutral, and you don't want to do that. So just if it protrudes a little bit is fine, as long as it's not touching anything else. One other tip is you tighten it, loosen it, tighten it, loosen it, tighten it. So like 3 cycles, and that really helps just compact the wires, because once you cut the insulation off, they tend to want to spread out. So you just want to make sure they're just nicely bundled so they're making a really good connection. Now we have to put in our circuit breaker, but before I do that, what I'm actually going to do is I'm going to wire my circuit breaker. So I'm going to measure off the distance, cut off the cable, and then make sure that I secure them properly into, in this circuit breaker, it goes into this little rectangular box, and then they get clamped down. And it doesn't matter if you go black, red, it's 120 on each side, so it doesn't matter which terminal they go into. But they do need to be torqued down, and that specification is usually on the side. Since we're using 6-3 wire, it's 6 gauge, so that gets 27 pounds of torque. The torque's important because you don't want these wires to loosen up after they heat up and cool down. They expand, they contract, and torquing assures that despite all that, they stay in place. Along with the torque specifications, there's usually a guide that tells you how much insulation you need to strip off so that you can make a clean connection. When you go to trim off the insulation, you may be tempted to use a tool like this that has a nice sharp edge down here that you can use to trim the insulation. The danger is that you'll nick the strands of copper, and you don't want that. So I find that you're better off using a utility knife. You make your cut going this way, just enough so that you can pull back the sheath, and then you cut around it to the desired length. And that'll eliminate the chances of damaging the strands. So here's a look at how I do it. Sharp tip is essential. I cut with along the way the strands are wrapped in the cable. And again, you notice I didn't go in deep. So there's the exposed strand, and there's a little piece of plastic cut up in there. Okay, and so let's say that's the length that I want. Then I just go around it. And again, you're not pressing very hard. You just want to score it so that when you pull on it, it does the rest of the work for you. And there it is, nice and clean, no damage to the strands. With the cable properly stripped, there should be no exposed copper outside of the circuit breaker. The insulation should go right up to the circuit breaker itself. With the circuit breaker properly wired and torqued, all you do is slide it in. What you do is there's a catch here, and what you're going to do is set it into the catch, and then you push down until it lays flat. It'll be a little hard because you have two strands that you're pushing against, but it is doable. So you catch the two hooks and just push it down into place. What every EV dreams of, its own charger. This is the Grizzly in from Canada. We're going to open it up and see what's inside. We opened the bottom of the box, so it's sort of going to reveal itself. And hopefully things don't fall over. So we have the white power cable. We have the no need to aim plug. This is where you store the handle. Our connector. Instructions, mounting bracket, and the actual Grizzly. And what I like about the Grizzly, besides the fact that you're able to get it in avalanche white, it's a special edition, but it's just white. Usually it comes with black cables, but you can request it with white cables. So I thought it'd be, nice to have that look. What I really like about this, 3-year warranty, UL approved. It's just a basic charger. It's like the charger you would find out on the street where you go and you just plug into your car, except this one doesn't need to call home. It's not like some of the chargers you can buy right now actually communicate back to the mother company. This doesn't do that. This simply provides power. It can provide up to 40 amps to the vehicle. My vehicle uses less, so it's kind of overkill at the moment, but kind of future-proofing, if you know what I mean. Anyway, solid box, no controls to play around with. You simply plug in the unit or hardwire the unit, and then you're ready to charge your vehicle. And because it doesn't use a smart app or anything, you don't have issues with that. My vehicle can actually control when it needs to charge and how much it wants to charge. I can set that in the vehicle, or I can just leave it wide open. That's up to me. So that's just one less piece of software that gets in the way. They do make a smart version of this, which does have an app. Then you're programming the app, but if your car has different programming, sometimes they conflict, and this will want to charge your car while your car doesn't want to be charged. This just eliminates that. It's solely on the car to accept the charge at whatever time I set it to. And because in the area that I'm in, we don't get any discounts at night, lower rates for electrical use, I can charge day or night, it's the same rate. So this just makes it really easy. With the Grizzly here, I know that it's 15 inches from the top of the unit to the plug, And with a cable length of over 20 feet, it'll easily reach the other side of this vehicle. And in the future, should we get a Prius Prime, we'll be able to charge that vehicle also. As we know from earlier, we have 25 feet of 6'3" cable coming down behind this wall. Ideally, you might want to bring it all the way down here so it's next to the other outlet, the 110 outlet, but I have a feeling that it's going to end up being short, so I'm going to put a hole here. And what I've done is I've gotten my box and I've trued the box with a level and marked it all up. Make sure when you mark for the hole opening that you include this flat part, not the tabs, but this flat part here, because that will have to fit into the wall, top and bottom. As for cutting into here, you can use a utility knife, multi-tool, a drill, a saw, various ways of doing it, whatever you're comfortable with and whatever tools you have. I happen to have a multi-tool. I really like that tool, so that's what I'm going to use to cut in here. Word of warning, don't plunge in, whatever your tool, don't plunge in too deep, because like I know in my case, there's a cable that's dangling in here, and I don't want to damage that. I know these cables are out of the way, but you don't know what's behind your wall. Just do your cuts very, very shallow so you're not going deep into the wall where you might hit something. So now I can tell that there's a stud, indeed, just about a 1/4 inch that way, so my line's going to be pretty accurate. When you've correctly sized your opening, the junction box should just drop right in and be flush. Now with that accomplished, all we have to do is pull the cable through, pass it through one of the tabs on the box, bring it out, and then we can wire it up to the receptacle. We pull our cable through and, oh boy, we're a bit short. What do we do now? Running short on your cable is never a good thing, especially when you're trying to make one continuous run from the power source to the end. So what are my options? Well, I could splice on additional cable and thereby get to any particular length that I want, but I don't like the idea of splicing. I'd rather just terminate at the connector and just have one complete run of this wire. So my other option is to go up higher and therefore get my additional cable that I need to actually dress the box and do all that. So I think I'm going to take these measurements, go up a little bit higher, and yes, that means my box is going to go up even higher, the EV charger box, but that's okay because it doesn't have any controls or anything that I need to worry about, so it can be as high as it needs to be. So we're going to just mark off a new area, and this should buy us an additional maybe 5 or 6 inches, which is all I really need. And then we'll continue on with the installation. With a new opening, we have plenty of cable coming through now. And the question is, how are we going to route that cable through this box? This has knockouts, and normally you'd put one cable through each of these knockout tabs that lock the sheath in. I'm thinking I may just put the individual wires through there. I don't know yet. But the real challenge is that you have to figure out which way your receptacle is going to be in this outlet. And in our case, because the plug ground is facing down, we want to make sure it's in that direction. And that's why I've put this little arrow there so I don't forget. Because if I put it the wrong way, then I'm just going to have to redo the work because that's not the way the plug is orientated. Anyway, now the other challenge is on the back side, the clamps are facing up except for the ground, which is on the side. So that means ground's going to have to come in and go down to the bottom of the box, and then the two hots and the neutral are going to need to feed right off the top, and there isn't a lot of space in there to maneuver this 6-gauge cable. So a little pre-planning and knowing which way you're going to face the ground on your receptacle will pay off later. I made all my wire connections without having the box mounted in, just for ease of being able to manipulate things around. Things you should know: there's probably a strip guide, and here's the one that came with this receptacle right here. So I knew how much to cut the insulation back so that the wires aren't exposed when they're properly seated in their positions. Ground is labeled. You have one that's called white for the neutral, that's labeled. And then the two other positions are red and black. They're not labeled because they're interchangeable. So fairly easy to figure it out. Again, make sure you know which way your ground needs to face for your particular device. Now the big challenge is getting everything back in the box and cushioned up. So I have some gradual turns in here, and I'm hoping that it'll all go back into the box nice and easy. Then once that's in there, getting this into the wall should be fairly easy, and then we put on our wall plate. And don't forget, each of the fasteners has to be torqued. Specifications for this receptacle is 20 inch-pounds for each fastener, including ground. Here's our box with the receptacle in place. It'll be a challenge because the wires are thick and they don't want to give a whole lot. One thing that I found useful was the back end of just a pair of pliers. You can push against the cables and the wires and get them to give without damaging. So make sure it's like rubber coated, and that'll help you get the wires in place. It's still kind of tough. Another thing that I found useful was when I was able to just push this, using the metal, I was just pushing down into the box. And then finally I dropped in a screw and that caught. Then I did the other one and I just got the very beginning of the screw, then dropped in the other two and slowly started fastening the screws to help get the box down. And as it started aligning and getting into position, then I just pushed down on the entire thing, and that allowed the screws to go in even further. And so after a lot of work, you should end up with 4 screws that are attached, holding the receptacle into the box. Now all you're going to do is just slide the box into the opening and turn this fastener and that fastener so that the flaps can come up, move forward, and hold the box in place. Here we are, the box is in place. That was relatively easy. The cable just didn't want to go back in this way. It wanted to go in that way. So I gave it a slight bend, and that just helped it get in there. Of course, tighten those 2 screws, so that got it in. Now we have our wall plate, and that goes like this. And there should be 4 screws that came with it. By the way, there's this plastic coating on this, so make sure you take that off. Otherwise, it'll at some point start breaking down and it'll get kind of ugly on you. But with this in place, and once it's screwed in, then I'll be able to measure and determine the actual position for the charger, so that when the cable drops down, it just plugs directly in here without any slack. It should be just a perfect fit. If the holes don't line up, then just turn the plate 90 degrees and they will. When you're finally done with the receptacle, it should look something like this. Note, the plug does protrude, and that's just to be expected. That's the way it's designed. Anyway, so and when we come back, we'll actually measure off so that we can put our EV charger up there, and pretty soon we'll be able to charge the car. We're looking at the back of the unit. This is the top. There's a mounting bracket that's included with the kit. It is a 2-piece set. The back side attaches to your stud or your wall. The front side is what's going to mount to the back of this box. So in order to separate the two, we simply grab the front, lift up, and then we just separate. We take this, line up the 4 holes with the 4 holes here. Top goes to the top of the unit. So it'll look like that. Then you take your hex screws and you'll tighten it down with a 4.5 millimeter hex key. And then you just drive in all 4 screws. With all 4 screws in, now you're ready to mount the unit. You've already secured this part of it to the wall, so then all you do is grab the unit, the charger, place it into the slot, release this, and it will just drop into place. And so the wall's here, this is holding up the unit. You have a pin that you can insert. And when it comes through the other side, it keeps it from coming off. And you'd secure that with this cotter pin on the other side. There's a little hole here for that pin, like that. And that'll keep this from separating. And great for an indoor unit. Obviously, if you're mounting this outdoors and you're concerned about somebody walking off with your charger, they do sell a device that goes through and actually locks and holds the pin in place. But for our purposes, this is great. This also gives you the flexibility that should you decide you want to take the charger with you on a trip or to a new location, it's just a matter of pulling this, taking the pin out, and you're in business. When mounting the wall plate, of course, I measured up, and what I did is I drilled a pilot hole, stuck a wire in there to make sure that my cable wasn't going to be in the way. Knew that I was all the way to the back of the wall, so then I drilled a hole, attached the plate, put the box on here, and discovered that it was just a little bit off from hitting dead on with the receptacle. So I abandoned that hole, came over here, readjusted my measurement 1/4 inch up, again put it a pilot hole, set the piece of wire in there, made sure the cable wasn't in the way, put a level up here, secured it, so now I know this box is square. And now I'm going to dry fit this one more time to make sure that cable just lines up perfectly with the receptacle. I've attached the Grizzly to the mounting bracket and my plug aligns nicely. I do have a slight curve, but that's okay. A little bit of that will straighten out as I square this up, because since there's only one screw holding that wall plate, as soon as I put the Grizzly, the weight shifted it a little bit. So I'll square that up once again, but I know that at least the height of that wall bracket is correct. So now I can secure it, and then we'll proceed to permanently mount the Grizzly. Here's the wall plate, the 2 fasteners that were included with the kit, and then the third that I applied just to be extra secure with the box. It is square, so all that's left to do is to bring the box up to it, and there are the catches, and just let it drop into position. Then we put our pin that goes through this hole, comes out this hole, and then secure that pin in place. Due to the limited access in this area, I had to use a pair of pliers holding the pin and come overhead and drop it into the hole of the shaft. It took a couple attempts, but as you see, we were finally successful. Here's the final assembly. Grizzly is square, coming down, and our receptacle and plug line up perfectly. No, I haven't pushed it in yet because I still just want to do some more work around here. With the circuit energized, we're going to take some measurements. These are our 2 hots, left and right. So that should come up to 240. We get 245, so that's good. Now, if we go from 1 hot to the neutral, we get 122. And if we go from the other hot to the neutral, we should also get once I make proper contact, 122. And then ground, 122, 122, and from neutral to ground, there should be nothing. Okay, so we know this circuit is correctly wired up and the receptacle is also correctly wired up because everything is where it should be. 220 across, 120 to each of the legs going off the neutral, same thing going off the ground to each of the legs, and then there should be no difference between neutral and ground. We've passed electrical inspection, so it's time to put this system to work. We plug in our unit, and we flip on the circuit breaker. With the 50 amp circuit activated, you get a blue LED above the eye of Grizzle that indicates that the system is fully functional. Now we have the ability to recharge anytime it's convenient for us by simply unholstering the plug, connecting it to the EV, and walking away. The charger will supply power until the EV tells it not to or the batteries are full. Quick update, it's been a little over a year since we passed inspection and we're very pleased with our Grizzly. Our free nearby EV charger is no longer free, so actually our Grizzly costs less to use, which is fine. You may notice that the blue Grizzly light is not on, and that's because we de-energized the unit in between charging because we're in an area that's just prone to a lot of electrical storms and we'd rather not expose our electronics to any surges. We're very pleased with our Grizzly and the ability to charge our vehicle at any time. If you found this video interesting or useful, give us a thumbs up, leave us a comment, join the subscription team, and as always, thank you ever so much for watching.